Okay, hello everyone, and welcome to the second and final day of our second annual Fall 6G Symposium. I'm Doug Castor, a Senior Director of Research and Innovation at InterDigital, and I'm here along with Professor Tommaso Melodia, who is the Director of the Institute for the Wireless Internet of Things at Northeastern University. Yesterday, we had an outstanding turnout of over 35 technology experts across industry and academia that provided their views on the path to 6G. We were also thrilled to bring experts and representatives from the US government into the discussion, including Congressman Bob Latta, Congresswoman Lisa McClain, and Congressman Bill Foster, as well as former FCC Commissioners Mike O'Reilly and Jonathan Adelstein. One of the themes of our symposium has been paving the way for North America beyond 5G. And in order to do that, we need government, industry, and academia to be working together towards a common plan and roadmap so that North America has a leadership role in 6G. In just a few moments, Mike Naraki will be giving a keynote to tell us about NextG Alliance, which is one of the partners for this symposium. And ADIS's NextG Alliance is a driving force in building this North American leadership. We'd also like to give a big thanks to the hundreds of attendees and participants we had throughout the day and hope that everyone will be joining us today as well. So thank you everyone for all the questions that kept the dialogue lively, and please do keep that up today. The moderators and the panelists are seeing all the questions and simply may not have time to address them all, but even if the questions are not addressed here, they are seen by the many others that are participating here, including 6G World, who may be able to address these questions for us in the future. So Tommaso and I also wanted to take a few moments to thank our co-hosts that have been working for months recruiting and planning for this event. Manu Gosian from Northeastern, Robbie Pragada from InterDigital, and Alex Lawrence from 6G World, who is the chief organizer of the 6G Symposium. So Tommaso, let's recap what we learned from day one.
So yes, I think in the opening session, we were joined by Robert Latta, a congressman from Ohio's 5th Congressional District. Now, he made the point that key components of our future economy, including healthcare, autonomous driving, remote work, will all benefit from developments in 6G. So Congress has to make sure that it has the right legislation in play so that innovation can flourish. The FCC also needs to make sure we have the necessary spectrum available, and we need to ensure that we take cybersecurity very seriously, managing supply chains and semiconductors, which came up also again later in the day for the government initiatives beyond 5G. So this confirms, I think, one of our key themes for this symposium, the fact that government, academia, and industry need to work together toward the shared vision on the value of 6G. So what were your takeaways from the keynote, Doug?
Yeah, the keynote from AT&T's Andre Fewich highlighted that while previous generations were more linearly focused on increasing speed and capacity, the next generation is going to be defined by its broader impact, healthcare, education, autonomous vehicles, and manufacturing, just to name a few. Andre also encouraged research in 6G today and called for distributed autonomous intelligence in edge clouds. And that underlined the need for more modular and independent and granular network components end to end.
Yeah, these are all key topics, I think, and the fireside chat that followed with the two former FCC commissioners also made the point clear that we need much more work, and the FCC makes no friends doing the heavy lifting in a sense, as they reevaluate the needs for adapting spectrum policy to make more bandwidth available in a more flexible way. Overall, I think we opened the day with a set of very insightful talks during the opening session.
Yep, and then we moved to the panel session that started with building a value proposition. And a big takeaway message was that we need to look at more than cellular technology to build 6G. We need to understand the social, environmental, and economic influencers and the dependencies that surround the technology. And this was really underlined by Michigan's Congresswoman Lisa McClain, who had a call to focus more on the nation's education system that will support the 6G workforce that we'll see in 5 to 10 years from now. And then we heard a similar point from MITRE's Andrew Thyssen later in the day in the government panel. I also highlight that InterDigital's Dale Seed suggested that we need to consider how to scale down when it comes to sustainability. For instance, how do we reduce power and use, for instance, wireless energy harvesting with batteryless devices?
Yeah, clearly on the topic of workforce development that you're bringing up, I think those of us from academia have a very important role to play, and certainly a lot of work to do to make sure that we train professionals with personalized curricula and the right skill set to innovate in this area. Then the following session focused on satellite and airborne connectivity services. There's a concern that there's relatively little that space-based capabilities can offer beyond coverage and resilience. But that said, I think the capacity versus cost balance in GEO is changing fast, while Irving Hudson, the VP for Telesat, underlined a change in mentality at LEO. It's about the network of satellites, not the individual one. And so as someone trained in networks, I love the idea that a satellite these days is a router with a fuel tank. An interesting point that was made also by Fatima Amdani of Kraus Amdani Aerospace is that national laws end beyond a certain height. And now that assets have storage and compute capabilities, we need to think about how laws such as data nationalization apply at height. There's no regulation, it's no man's land.
Yeah, the router with the fuel tank, I think, is an image that's stuck in everyone's head. So then we moved on to the revolution in the air interface panel, where there was an interesting discussion on reflective intelligent surfaces. And Emilio Cavanese from CLT mentioned the advancements made in the European project RISE 6G, which used configurable reflectors to help with terahertz propagation. However, Cohere's Ray Dolan did not think that moving to terahertz for 6G was needed, and that the world already has a lot of naturally occurring reflections that we can do a better job leveraging with the Doppler, with the delay Doppler optimized modulation scheme. And then AI and cloud crept into the conversation, which was, I think, indicative that the physical layer innovation for 6G may be very interdependent with those technology areas. For instance, Charlie Zhang from Samsung suggested AI could be designed natively into the PHY for 6G, whereas NYU's Tom Rosetta was a little bit more skeptical on the use of AI for the physical layer, at least.
Yeah, and the second part of Revolution in the Air focused on spectrum. I think there were lots of interesting discussions on spectrum sharing in the mid-bands with Monisha Ghosh from University of Chicago, Andrew Clegg from Google, bringing up a lot of interesting points. But also, I think for the first time, we had discussions on spectrum sharing at high frequencies. There are incumbent users, especially in Earth exploration in the high frequency bands, and not everyone agrees that we'll be using terahertz in 6G. Several experts are arguing that the millimeter wave range can handle the 6G requirements, leaving terahertz to maybe 7G or beyond 6G, but our Joseph Journet instead believes that terahertz will be an important part of 6G. And he made the important point that everything that makes it hard for the signal to propagate makes it also hard to intercept it. So there is, at the very minimum, a security use case for terahertz in 6G. I think there could be more as well.
Yeah, so then the last panel of the day was the government panel, and we were pleased to have Illinois Congressman Bill Foster. The congressman underlined the need for more understanding of telecom technology in Congress, as well as the emphasis on security. And he said that a secure digital identity is a fundamental right of every American. The importance of fundamental research was also raised, and the congressman cited academics and integration as being important elements to keep the pipeline of talent to support this research that will lead to American success.
Yeah, that was a very interesting panel and great points, I thought. So Tiaga Nandagopal from the National Science Foundation made a lot of important points also on the role of academic research and how things are changing on that front. The industry is working increasingly with universities, And that is also consistent with my experience. Our industry collaborations at Northeastern have been growing exponentially in the last couple of years. He also argued that next G is driving convergence to levels that we haven't seen before, such as having robots and AI communicating in real time. Think of Skynet in the Terminator movie. I think last we had Sumit Roy from OUSD and Andy Thyssen from MITRE and Mark Hahn from Lockheed Martin. They all made the point that the defense industry needs to do better at reaching out beyond its silo to influence the development of technology outside of defense and sharing its research. And I think that this is already changing. The fact that all of these entities are participating in the 6GSymposium is certainly a testament to that.
Okay, thanks, Tommaso. Yeah, day one was great. And so now it's time to get day two started. So it's my pleasure to introduce our keynote speaker, who is someone I met about a year ago, and someone who has similar thoughts to me about the need to get moving on 6G research. So Mike Naraki is ADIS's Vice President of Technology and Solutions and focuses on strategic initiatives to advance ADIS's member business and technology priorities. Mike has an extensive career with major service providers, including AT&T and Verizon. And at Verizon, he was the director for standards. So Mike, the floor is yours.
All right, thank you, Tommaso. First of all, I'd like to just thank the sponsors and the organizers and the panelists and the speakers. I mean, day one was a really successful program, and we're just really at the beginning of day two. So we look forward to some great panelist discussions. So before I jump into kind of talking about the Next G Alliance, I just want to acknowledge there were a number of references made during day one discussions, and just from a few of the Next G Alliance leaders, a few things I noted. You know, Andre Fuchs from AT&T, who is the chair of the Next G Alliance Full Members Group, you know, made the comment. I paraphrase. You know, every company has their own 6G vision and business plans. 6G, a view of 6G trends, products and services, but it's really kind of this collective impact of the alliance, you know, collaborating with government, industry, and academia that will move the needle in terms of leadership. There was also some discussion during the value proposition segment with Jeremy Nasser from Verizon, where Jeremy talked about the fact that you know, we absolutely need a focus on the 6G marketplace in North America, but also understanding that everything we're doing is part of this global ecosystem. And then finally, Andy Thiessen from MITRE during the government role discussion, you know, talked about the Next G Alliance not being a standard development organization influencing standards, but really dealing with a lot of the spectrum needs issues, spectrum sharing, spectrum management perspectives that have to really be solved in the same kind of timeframes as standards. So these are all kind of really good opening comments and tied well into our discussion. So this morning, I'd like to talk about the Next G Alliance, and not only the structure and what we've been working on since launching all the working groups a few months ago, but also the approach. You know, why is this the right approach for this region of the globe? Why would this help promote leadership as we move toward the, you know, kind of the full vision of 6G throughout this decade? So let me jump into, if we could move to the next slide. I just want to make kind of a brief mention. I realize many of you know ADIS, some of you may not know ADIS. You know, ADIS has for several decades been a leading standard development organization. You may also know us as the 3GPP North American organizational partner through all the various generations of mobile technology. So this is how companies in North America or government engages and participates and contributes to 3GPP in the development of the mobile specifications. But there's much more that we do. And so I want to make two key points. The first is one of our real focuses is really on advancing ICT industry transformation. And that, you know, that transformation is not just happening in this very kind of narrow communications path in the industry, but it's really this industry kind of focusing outward into all the adjoining industries. And so we see more and more of how the information communication sector is impacting and being impacted by, a number of industries, traditional industries, but also if you think about industries now like telehealth and smart agriculture, smart factories, and so on. So it's very much that kind of transformative path of the industry right now. And then the other point I'll make is that you cannot really look at 6G or 5G for that matter in isolation. It's really somewhat related to all these other areas around security and privacy and all the markets that encircle communications right now. So it's really kind of bringing this wealth of knowledge. And so this is one of the reasons why ADIS launched the 6G, the Next G Alliance to address 6G. And this has really been one of our most ambitious projects so far. So I'll go through now and discuss in more detail kind of the motivation and how we're organized and where our main focus areas are and where we're going next. Next slide, please. So really going back to about 16, 18 months ago, the ADIS board of directors, in a very visionary manner, undertook discussions around how do we create North American leadership for 6G many years in advance. How do we bring industry and government and academia together on this? And this led really to a call to action, which allowed us to really kind of approach government at a senior level and talk about kind of this thought process and where we want to go next in terms of alliance. And I guess the resounding response we received back, and this is in the 2020 timeframe, was this is exactly the right time to launch this. This should be stood up by the private sector, launched, go out and create your partners, develop the mission, develop the working structure, and so on, with the full knowledge that we would certainly be re-engaging government as the alliance unfolded and we began to get deep into the into the work stream. So that was kind of the first touch point with government. We then took that feedback and the feedback from our members and put together the construct of an alliance. And again, throughout this process, the concept of it being a private sector-led initiative, remains. The real goal was to really influence actions and government with, and also the 6G research communities. This has a very action-oriented agenda. So, while we're creating documents and we're creating reports, and that's a natural way to convey recommendations and so on. The real goal is not to stop, with the development of documents, but really to focus in on driving outcomes, and the concept that from the standpoint of industry and government and academia, we're all in this together in terms of trying to drive North American leadership. We've really grown from initially 16 founding members going back to the end of last year to over 75 members now. And we continue to get inquiries. We continue to add new members. I can provide some more detail on that as we go through the discussion. We have really grown, not only in terms of just commitment on paper, but really commitment of resources from our members. We're well over 500. Actually, we're getting ready to eclipse 600 participants right now, experts that are really meeting on almost a daily basis across all these various work groups, and providing their thoughts, their insight, their contributions, and helping us to shape a really important outcome. So let me come down maybe one more layer now, if we can go to the next slide, please. So the question is, what are the basic foundational goals for the Alliance? And so while we have many goals, I think there are really kind of three key areas. The first is the belief that NextG really needs to kind of rise up to a national agenda level. And the reason we're saying that is because NextG is not just about, faster, better communications. As we've seen over the last year or two, the whole communications information infrastructure has been so key to the continued economic stability of the country, of this region, and we see that even happening more so as we move ahead. That 6G will really find itself in so many industries and verticals and enterprises and consumer business units that it's really key to the continued growth at a national level. And I guess I'll make one clarification in terms of next G. The often question is, well, what is the definition of next G? We've really defined it as 6G and beyond, end of decade vision. But we also understand that 5G has a very long evolutionary path, and there's going to be great advancements made, throughout this decade. And so 6G is not kind of a remove and replace view. It's really building on the accomplishments and successes of 5G, and it will be, be very much dependent on many of the things we learn throughout the deployment cycle of 5G. The second area is really adopting a view that works in this region. There, obviously, everyone's aware of what's happening right now, in Asia, in China, in terms of building a strategy around manufacturing technology and standards dominance. Japan, of course, doing a lot of funding right now of the private sector to develop 6G research. Korea, major investments and making big promises in terms of market availability of 6G during this decade. And of course, within the EU, we have numerous projects like Horizon Hexa-X, 6G flagship, and so on. They're looking at research platforms. But the real question is, what makes sense for this region, considering our values, our economic structure, our political structure, our policies, the individual markets, within this region. So that was the real focus, to develop a model that works within this region. And finally, all this has to lead up to really a 6G marketplace. And that marketplace is obviously deploying in this region, but it's also looking at basically selling into the global market. So these are kind of underpinning foundational goals that we have discussed throughout the formation and have carried through the working activities. Next slide, please. So talking about this very quickly, this is a really important slide in terms of approach. I mentioned talking about the approach, and I think this is basically the view of how in North America we can win. And the view is that basically the Next G Alliance was put together to develop the strategies and the priorities, recommendations, do the deep analysis, come back to government, funding agencies, research communities with a collective view of what are the big technology drivers, what are the big technology development areas where we need to invest, what are government action recommendations coming from the private sector. So it's really kind of working alongside government to create a very holistic approach, but the continuum along the bottom is really critical. And we think this is where we differentiate ourselves from what's happening in other parts of the globe. We're really see the need to tie together what's happening in the area of research with what comes next in terms of developing solutions, developing products, onshore manufacturing, incentivizing the manufacturing community in that respect. Standards leadership, not standards development, but that'll take its own course, but standards leadership in terms of making sure that North American requirements and needs make their way through the process. And then this all really points to areas of next year readiness and commercializing technology. The real key here is that all these things have to really tie together. These are independent activities. And so you could easily see how something like in the area of research, important research area, applied research areas, could give us an 8-year glimpse into what would be the job skills of the future. What would be the skill sets, which then kind of ties back to education, academics. So this is kind of holistically where the approach that Next G Alliance has adopted, and we have discussed with government, we discussed with all of our partners, of course, and this is what we believe in the end will provide leadership. Next slide. Want to just briefly talk about the members who have now grown to over, the full membership has grown to over 40, and what you see are companies that build networks, companies that develop the infrastructure, develop the devices, develop the software. You see many specialized companies, you see companies in the testing area, and you see other companies that don't always traditionally participate in these collaborative activities. So we're very pleased with the full membership growth. We feel like we really have kind of hit the market at exactly the right time, even maybe a beat or two ahead of the kind of the 6G perspective. And so we certainly plan to continue to grow our full membership and depend on them for our strategy and guidance. Next slide. I also want to mention contributing members, which are obviously just as important as our full members, but these are companies that perhaps have more specialized business missions, companies that are in the research area, research labs, research institutions, and very importantly, we've had a number of academic institutions join us, many who are both sponsoring, participating in this symposium. They are really bringing a great deal of thought leadership to the development of the various work streams within the Alliance. We expect to continue to grow. And as we get into areas that go beyond some of our initial kind of paper documents, this would be very important in terms of validating our conclusions, our recommendations, and developing what comes next. And I'll make one other comment before we move on. Some recent news, the full member group has just approved a new class of government membership to the Alliance. So we have a very, in the coming weeks, a very coordinated program now to reach out to government agencies and allow government to contribute their needs, their requirements, their perspectives to what we're developing within the Alliance. And we feel that will really kind of create the final linkage to really a strong collaboration between industry, academia, and government. Next slide. Of course, a good, good strong alliance needs strong leadership, and so Andre and Jan have been at the helm since day one of the alliance. In fact, as they were present during all the original development of the whole strategy and formation of the alliance. So we're very appreciative to their leadership. Also, the steering group leadership, which basically owns all the deliverables and work products and so on, is very important to us to have kind of balanced leadership across kind of the vendors, the infrastructure vendors, the operators, and the very importantly, the hyperscalers. And that also kind of represents our general membership. All these individuals have brought strong leadership and perspectives to what we're doing and have kept us on course in terms of our original mission. So we're very thankful for that. Next slide. And I guess one final kind of key point in terms of our structure is, given the complexity, we have, if we combine all of our working groups and committees and leadership committees and so on, we got almost a dozen activities. We've got, hundreds of participants. It was really important to Addis to have a technical program office to make sure that we deliver on our commitments, that we tie all the various activities together across this very large set of resources and work activities. So we're very pleased. We selected Virginia Tech Applied Research Corporation back in the June timeframe to run the technical program office. I think many of you probably know Eric, through his days at the White House and the FCC and in industry and now back in academia. But along with that, VTR brings a very strong leadership team that has a great deal of experience in terms of strategic programs, operational programs, and so on. So again, I think that kind of closes the loop in terms of having a kind of a well thought out and orchestrated process, not just for this year, but for going forward. Next slide. Okay, I want to just kind of pivot toward the end of the remarks to kind of where we're focused this year. And one of our commitments has been to deliver on a vision and roadmap by end of year for publishing at the beginning of 2022. And so we've adopted a kind of this multi-layered approach to 6G vision. And I wouldn't necessarily call this bottom up. I wouldn't necessarily call it top down. I think what we view is that there are a number of layers, and given that this has such a diverse audience, we really felt it was important that we relate the results in terms of these various layers of understanding. So at the national imperatives level, there's kind of this view of the kind of big economic drivers, societal drivers, policies, government needs, things that are very kind of at a very regional, national level. So you can think of things like closing digital divide, digital equity, energy sustainability, privacy, economic competitiveness. These are kind of the big national imperatives that should kind of be overarching how we look at this future vision. And then there's a layer that basically looks at applications and markets. What will be the markets that will be really relevant if we take a end of the decade view in terms of dependency on 6G or being enabled by 6G? And then you begin to think of all the application classes, not necessarily down to kind of the killer app or kind of predicting a small number of use cases, but taking a very kind of broad view of the applications that are going to span kind of holographic services, digital twin, digital replica, ultra high positioning applications, multi-sensory applications. So this is where the innovation comes. This is where development comes at an essential layer. And then of course, for the technologist, the technology development section, which if you start to kind of decompose all the various technologies that will touch 6G, our technology team has already kind of identified 50 key areas that they're starting to dig into that touch upon, not only radio systems, but also the devices, the subcomponents, kind of the basic things that are underlying the networks, how networks will be changing, the concepts of distributed cloud, native cloud, cloud compute. So this is kind of our structure. The idea is to communicate the vision across these different layers and really allow whoever the audience is at whatever level to have a good understanding of the vision, where this is going, and to create all the connections between each layer of this vision. Next slide. So I want to just kind of give a glimpse into the roadmap of the national 6G view right now, and that is really kind of what ties together where we are today to where we want to go in terms of a very robust 6G marketplace. And so up front in this process, as it should be, are kind of all the key drivers we just talked about, the things that will basically be driving the market. And then you build on top of that, all the government actions and policies and recommendations. What are the basic needs across the organization? What are the core technology and applications? All these things will eventually kind of spin up and move closer to some of the market readiness concerns and things like operational needs. So the idea is basically take us from where we are today to this vision that we create around the 6G marketplace with an action-oriented agenda of what needs to happen and what time frame and what priority. And that's really kind of the whole basis of the roadmap itself and what we plan to deliver early in 2022. All right, next slide. So just kind of finishing up, just to give you a sense of the structure. We've got these working activities that are going on. Again, I mentioned the National 6G Roadmap Group is kind of a foundational point for integrating outputs from many of these groups. But just as important are, at the front end of this process are the societal economic needs group, the drivers, the application drivers that are part of this, the Green G group that's developing sustainability recommendations. They'll be producing a white paper in the coming weeks. And then we have kind of the deep technology development, and we have the spectrum group, which of course is looking at things from in terms of positioning spectrum to be market ready and the amount of time it takes for those things to happen within the industry, within government, and so on. So that gives you a kind of a snapshot of what's happening within the Alliance. We can go to the last slide. I just want to finish up and thank everyone. If you'd like any additional information, you can certainly go to the Next G Alliance website. You can contact me directly. We would very much like to welcome new members to this approach. We expect to continue growing the organization and growing the program as we move ahead. Thank you, and back to Doug.
Okay, thank you, Mike. There were a number of questions. I don't know if you had the chance to see them. We can probably have time for just one of them if you'd like to maybe take a crack at that. Would that be okay?
Sure.
For instance, the one question which got the most likes, I think that's the way we should do this, right, is really, and I think you have touched on this a bit, just when we think of a generation of cellular, we often think about 3GPP standards bodies and the evolution of waveforms. But how should we be thinking about 6G and the breadth of 6G? And I think you did touch on that, but maybe since it got so many likes, you could just elaborate on that a bit.
Okay. I think we're taking a much broader view. I mean, 3GP has a certain context, and because the way standards are done very sequentially, very systematically, there are releases and there are generations and so on. But we're taking a much broader view of this is really an end of decade view, more of an aspirational view. What do we want the vision of 6G to do? What do we want this to look like? So it gets beyond simply specifying requirements for mobile technology. It's a much broader view across all the adjoining industries and how this will impact society, how it will impact government, the economy, innovation in general. I hope that answers the question.
Okay, yes. And I see there's a number of other questions. Some people would like to contact you, so we'll make sure that we get their names. Saragana, I see, has some comments here, would like to reach out to you. Okay, so let's move on. We're a few minutes behind schedule. What I'd like to do is just really rapidly kick off the next session today. And that will be from, we are going to be moving into a session on how 6G can deliver to industries. And I'll hand this over to Mike John from Digital Mind State to kick off our first panel. So Mike, kick it away.
Perfect. Thank you so much. Everybody can hear me?
Yep.
Just want to make sure. Perfect. It's amazing how over time we've gone from 0G to 5G and things have really kicked into high gear. I think back to 2G, allowing us the ability to send texts and pictures, to 3G, internet-based applications. 4G, we advanced to streaming videos and games, rich multimedia experiences. And then 5G has really ushered in no loading time sharing, low latency, and the birth of what I like to call the immersive entertainment experience. With that being said, 6G, doors are just wide open. We have holograms, the Internet of Things, wearable tech, mixed reality, autonomous cars, cars watching other cars. One of the things that I'm really impressed with is that 6G has the ability to impact the economy. And this means education, government, work, and mobility, ocean, land, sky, and space. And there's a lot of talk that's going on regarding space travel, civilians going into space. 6G will play a big role there. I'd like to open things up. Today, we have a rockstar panel that will be discussing the transformational process of 6G here in North America. And so with that, I'd like to start off with Joy Deep. If you could introduce yourself, and then we'd like to pass the mic.
Hello, everyone. It's a pleasure to be here. I'm Joydeep Acharya, Senior Manager from the Silicon Valley Research Center, part of Hitachi's global R&D based out of North America. And so it's my pleasure to talk to you about what we feel is 6G and how it would contribute to our lives. So if you really think about it, so every 10 years or so, we have a so-called next generation in terms of technology. So we had like the 4G around 2010s, and now we are in the 5G era, and then 2030 to 6G. But moving beyond that, if you think really of new business impact or new business value, so we have every about 20 years or so. So you could say 3G and 4G was more about optimizing mobile broadband experience, whereas 5G and 6G, the key thing is going to be what we like to call social innovation. So really, how do these networks deal with social infrastructure? How do human beings deal with social infrastructure and impact us, like industries, transportation, power and utilities? So that is the key. And this process kind of started in 5G already. So we is the first time where a standard was developed, keeping machines explicitly in mind, like how to do building energy management, how to optimize manufacturing, mobility. And this trend will continue in 6G, where we take a much bigger view where all these individual verticals sort of coalesce, and we're really thinking about smart cities at scale or mobility as a service in scale. So that's, I would say, the social innovation aspect. That's the key thing. And if you really think of it, way back in 2015, all the member nations of United Nations, they adopted the UN 2030 Agenda for Social Sustainable Development. And as a result, 17 goals for sustainable development goals were signed. And 2030 is also the year when 6G is expected to come to like commercial deployment. So this really is a big opportunity for us to really seize, take the bigger picture and kind of act upon those goals. And we do have a lot of features of 6G that will enable such grand visions. And I'm sure we have heard about this in day one. It's will really be developed from perspective of machines and how humans interact with machines. And we talked about immersive multimedia. We have XR, holograms, digital twins, and really by 2030, we will have like way too many machines. I mean, according to some reports, there will be like close to 500 billion machines. So we do really have to have 6G to really be able to optimize for such a new kind of a situation. And AI is going to be very, very important. Right now, we do have AI optimizing individual layers, but we would, beyond that, we will be looking at how AI does end-to-end optimization and real-time sensing and control. And we at Hitachi have been right in the forefront of some of these deployments. As you know, we have a lot of factories and industries worldwide. And currently, we are looking to see how 5G can benefit from 5G deployments, can help some of the use cases. And as Mike mentioned, when we think of 6G, it's not really a replacement of 5G. It's more like we have current 5G deployments, we learn some things, and we see how we can do better in 6G. And that's exactly where we are at. Because even if you think of factories, it's not just a big term. There are many different kind of factories. We have certain factories which are, I would say, sort of old-fashioned. There are certain factories that are much advanced. There are factories which do process manufacturing. There are factories which do discrete manufacturing. So for each different factories, the challenge of is different, and that's what we are sort of learning currently. So if you go to the next slide. So this could be one of the ways how we can envision how we are going to transfer sort of the journey from 5G to 6G. And this is currently based on a national project based out of Japan. But we are hopeful that we would be able to introduce something in US as well. So this is an example where we have broad deployment. So in the factory shop floor, there are human beings, there are automated guided vehicles carrying, transporting stuff from all over the factory. And there are issues of how to optimize the routes, how to ensure safety, because there are human beings and there's moving vehicles in play. And so this project kind of would be, the plan is to have it somewhere on 2015 and really do an optimization end to end, use sort of 5G or a post 5G radio network, an edge computing to really bring low latency processing. And positioning here is very important because of what I mentioned. And also looking at how to do cross-layer federated learning at the cloud and the edge level. And the end goal of all these separate activities is what I think is the really like an application for 6G. Like we always talk about what's the killer app. That's the common question. And while in 6G there's no one single killer app, but I believe that the broad class is going to be the collaborative digital twins. So how do you bring everything together and make a digital twin, not only of a single machine, which sort of exists today, but of the entire factory process where we have a machines and human beings and processes interacting together. So with that note, I would like to end and hand it over to my next panelist.
Perfect, perfect. Thank you for an outstanding job there. I'd like to turn it over. Who'd like to step up next to the mic?
I'll do it.
Perfect, Charles.
Okay, hi everybody. I'm Chuck Byers. I wear two hats. I'm the Associate Chief Technical Officer of the Industry IoT Consortium, which up until a few months ago was known as the Industrial Internet Consortium. Same acronym, slightly different name, same people and mission. I'm also CTO of a little startup called Valkyrie, and we make landing stations and mailboxes for drone package delivery. So I'm going to try to mash up those two CTO roles that I share into a viewpoint on why 6G is so essential to these industries and how we might be able to benefit best from 6G in an example use case. Next slide, please. So here's my laundry list of kind of what I think the industry needs out of 6G. First of all, 5G is working pretty well and is likely to work pretty well for the next decade. It's got almost adequate bandwidth. The privacy and security are pretty solid. A few coverage problems, especially indoors, but I think we'll cover those with techniques like neutral host networks. So I think we're doing okay, but we're not facing a static set of requirements. This stuff is mushrooming in terms of what we're going to ask these networks to do in the coming decade. And we need 6G to be ready for that. So I think some technology advances are definitely in order. More bandwidth is absolutely essential. When was the last time people said this is enough bandwidth? It's always going to be more. There's always going to be more connectivity, more users, and more bandwidth per device. So think about a drone flying around delivering a package. It might have 6 UHD cameras on it, up, down, left, right, front, back, all of them having to be backhauled into a network for image processing and archiving. It might also have LiDAR sensors and significant bandwidth for the uplink and downlinks for the flight telemetry. So these devices may provide a load on a network similar to multiple current generation cell phones. We think that user count and device count is going to explode too, with IoTs and wearables and all the different smart and autonomous vehicles. By the middle of this decade, we expect there to be around 50 billion IoT devices connected on the internet. By the time 6G hits its stride, perhaps 10 or 12 years from now, I fully expect that to be well over 1 trillion connected devices, 1 trillion individual things that we can address, send messages to, receive status from, and so on. That's over 100 devices per human on the planet. So we've got to do something to provide the necessary connectivity to those devices, both in terms of reach and in terms of bandwidth. I also really am a strong advocate of edge computing. And I think edge computing is just getting started right now. Cisco has mentioned that edge computing by the middle of this decade is likely to touch around 40% of the total traffic on the internet. And I suspect that that percentage is going to increase as we head up towards 6G. We also need 6G to increase the levels of hierarchy of that edge computing, not just a filing cabinet size gizmo at the base of every cell tower. I think we're going to see lots of edge computing in microcells and nanocells and picocells. I think we're also going to see edge computing as a network intrinsic capability on many of these endpoints. So there'll be a corner of the processing in the intelligent endpoint dedicated to running the 6G network, and that can be considered a part of the edge computing hierarchy. Network management and the complexity associated with it is really an important consideration. If we're talking 1 trillion devices, there simply not enough people to put in swivel chairs to type an IP address per device. This stuff has got to all be automated. It's got to all be plug and play. It's got to self-discover its capability. It's got to self-administer its security policies, and so forth. The Industry IoT Consortium talks about trustworthiness in 5 different dimensions: security, privacy, safety, reliability, and resilience. All of those are going to need constant improvement. All of those are going to need tuning up as we head towards 6G. Security in particular is going to be very important because the stakes are going to be higher. If there's 1 trillion devices, maybe a few billion of those are going to be life critical, running things like anti-lock braking systems. We definitely don't want ransomware attacks under those circumstances. And the network is the first line of defense in terms of preventing against those kinds of security vulnerabilities. Finally, there's simply not enough radio spectrum to run lots of radio for lots of long distances. We need to be very efficient and economical about the way we dedicate that radio spectrum. And I think that means that 6G architectures need to support very deep penetration of fiber connectivity and very fast fiber connectivity. Today, state-of-the-art fibers are running at 400 gigabits per second, well over terabits, multiple tens of terabits potentially by the time 6G hits. 6G architectures need to acknowledge the fact that radio is not the end of the world in terms of connectivity. We really need to get a large proportion of the bandwidth times route miles driven to fiber as fast as possible. I'm a serious detractor to folks who are talking about radio-based backhaul systems for 6G nodes. All that does is takes the traffic that we're running on the radio interface and sort of doubles its spectrum capacity because we now have to use precious spectrum also for backhaul. Let's not do that. Let's figure out a way to get fiber deep into the network. All right, on to the next slide. Let's have a look at a particular 6G use case. And this slide's got some builds on it. So here we see a smart city. And there's a bunch of cloud services and a bunch of links potentially provided by 6G. And they're helping us with intelligent residential and commercial optimizations. There's an intelligent hospital there. We have intelligent transportation systems, more suburban residential things, intelligent manufacturing, agriculture, education, medical uses, and so on. These are all the applications that we would see for 6G. One build, please, if you could run the slide forward. What we'll see next is the addition of drone package delivery services to supplement, and for many types of packages, about 70% of the packages, replace the diesel trucks that are running around delivering our Amazon packages today. We do this with a number of landing stations and a number of drones flying around the sky, making missions between those landing stations to collect packages, fly them to their destination, and drop them off in a far-end landing station. These landing stations are fairly sophisticated. They have edge computing capabilities built in. They also have lots of robotic things to unload packages and store them in lockers and do that kind of stuff. So as you can imagine, there's a significant amount of interconnect involved in this very large network of very sophisticated devices, including the drone airframes as well as the landing stations and other ground support infrastructure for this. So let's see how 6G might help us with that. Next build, please. What we have here is the 5G core morphing into the 6G core. Next build. And here we have a bunch of macro base stations. These might be 5G or 6G, and these are typically, on a tower with electronics the size of a filing cabinet below them. Build it up again. What we then do is put a bunch of micro base stations around. These could be kind of the size of a shoebox, very comfortable on a light pole or something like that. And there'll be many more of these distributed much tighter in the landscape. Next build, please. What we see here are the nano base stations, the tiny little ones, maybe the size of an Altoid tin, that are distributed very deeply across the landscape, perhaps much more deeply than, say, Wi-Fi access points are today. And the final build shows that all of this stuff needs to be enabled with edge computing, because we need to calculate different functions, especially for this drone package delivery service, at all these different layers of the network. There's edge computing flying on the drones. There's edge computing associated with all of the cellular network interconnect. There's edge computing associated with with all of these landing stations and other ground support infrastructures. So all this together represents a cohesive model of how drone package delivery and 6G represent a very cohesive model for how these services might be assembled. Thanks. On to my next panelist, please.
Perfect.
This is Ben. I could go next, Mike.
I really enjoyed that presentation. I wanted to open up one quick question. Should we think about 6G as a technology or a set of technologies, or should we think about it more holistically?
Well, my view is it's very holistic because it's not going to work in isolation. It has to talk about the software that runs it, the security posturing associated with that software, the backhaul fibers, all of the connectivity in the backhaul network, the mobile devices. It all has to be managed as a whole in order to provide that trustworthiness, that reliability, privacy, security, as well as the high bandwidth performance that these services would require.
What do each of these major challenges towards getting to the final potential of 6G stage? What are some of these challenges that we see thus far?
Well, certainly we're struggling with the security challenges right now. The famous ransomware attacks that happened a couple of months ago are just the first shot in that war. I think that we're also doing lots of interesting research on the radio interfaces. So, what it means to go deeper into the millimeter wave bands and even into the terahertz bands. Can we replace radio with light? So lots of people think that Wi-Fi, visible light communication sorts of functionality ought to supplement the radio interfaces in 6G. And I tend to believe that and agree with that because there's lots more spectrum available in the light spectrum than there would ever be in the radio spectrum, even with terahertz systems. So there's lots of opportunities for technological innovation that I think are going to really help us out.
This is awesome. One of the things that I'm really fascinated with 6G is how it will usher in the future of work. I look at the next 10 years as more important than the last 100. I want to open this up to everybody in terms of what they may feel 6G will bring to the table that advances humanity as it relates to 5G.
Yeah, I can maybe comment on this. I'm Harish from Nokia Bell Labs. So I think what we can expect in 6G is much more interaction between humans and machines. So this coexistence of humans and machines will be enabled by richer representation of the physical world in the digital world. So we can collaborate across factories, collaborate with machines. And this is likely to change how we train for work and how we are able to manipulate or control the machines to do what we want. It's all about offloading the right type of tasks to the machines, perhaps more intelligent tasks in the future. But in the end, I see this enabling of coexistence between humans and machines as one of the big differences that 6G will enable.
Thank you so much. I'd like to turn it over, Ben. I'd like to hear a little bit your input on 6G deliverables.
In general, to answer the question, is that what you're saying?
Yes.
I think in addition to the immersive experience where you could do more remote operations, to the point that was just made by Harish, I think it also allows us to provide additional intelligence into the operating environment. So predictive maintenance, being able to predict failures before they happen, which could be a huge safety upside for us relative to aviation, as well as automotive kinds of verticals where we've got probes and information being collected, analyzed by AI/ML technologies and programs to actually predict what's going on in the field, and to ultimately have interactive and autonomous supply chain systems across companies to provide parts before they fail and ensure that we keep systems running better and faster and more reliable.
Perfect. Good answer there. Harish, I'd like to hear from you in terms of what you feel the transformational process of 6G looks like here in North America.
Yes, so maybe if we can look at the slides I sent, that will be useful.
Mm-hmm.
While it's coming up, yes, thanks for that. So yeah, my name is Harish. As I said, I'm based here in Murray Hill, New Jersey. I lead the radio systems research in Nokia Bell Labs. Our vision for 6G, in the next slide, is about bringing together the physical, digital, and biological worlds. So we believe that humans will not only inhabit physical worlds, but also very rich, dynamic, high-resolution representations of the physical world, which we call the digital world. And these will coexist, and we have to be able to interact with them in a smooth and unified manner. And all of this leads to augmenting human proximity. So if you think about what wireless networks are all about, they're about bringing experiences closer to us, be it a voice call, video. What we see with our eyes, we are able to see something that's far away. And this evolution of human proximity augmentation is going to get to the next level with entire digital worlds coming in front of us. So we can experience new worlds as though they're right there. The next one is about augmenting human intelligence, which is expanding our abilities to do analytical tasks, because more and more of the machines will be infused with intelligence. And again, the network and the 6G era technologies will play a big role in enabling this augmentation of the human intelligence. And then finally, augmenting human productivity. And this is all about enabling our control of machines. As I was just answering to the previous question, how well can we offload tasks? How well can we interact with robots? And how robots can interact with each other. So all of these things will be substantially be enabled in the 6G era. And if you look at what are some of the transformational technologies, if you go to the next slide, please, that we will see. And I try to be pretty concrete here with what is possible in 5G advanced, and where we are going to go with that in 6G. So we will see augmented reality in factories, in healthcare, education, in 5G, as 5G gets more extensively deployed and 5G advanced gets deployed. And these would be for use cases that are fairly high level, in the sense that reading a manual or some low resolution tasks. And where we see that going is enabling even remote collaboration, collaborative co-design between factory workers, where you need to have a very rich representation of the workspace in order to be able to manipulate both physical and digital objects and work together with somebody else. And the means to get there is really to enable much higher capacity and data rates, and also use of machine learning and artificial intelligence. The second one here is on ultra reliable low latency communications and the time sensitive networks. And 5G is targeting this with a 1 millisecond radio latency, 7 nines reliability, etc. But there's a price to pay for this, in the sense that the capacity and the spectral efficiency we achieve with that is not as good as it can be. And that's something I think 6G will improve on. It's going to improve the new use case of the previous generation. And so making the low latency communications more efficient through joint design of communication and control. So that's one thing that 5G did not really do well. Like, what do we really need to do in terms of communication for the actual control task at hand? So taking more of that would help with the efficiency. And the other interesting thing that we are thinking about for 6G is, as digital twins get more common, so the factory represent very well, how can we exploit that to make radio more reliable, and vice versa? Represent radio signals in the digital twin to have a twin of the network, etc. So that's something new we can see in 6G. The third one being Internet of Things. We heard about how many devices there are going to be. And today we have low power, wide area IoT solutions. But we're going, I think, into the next generation with completely battery-less devices, zero energy devices. And the enabling technology for that is going to be backscatter-based communications, energy harvesting. And imagine how many more devices we can have if there are no battery devices. They're really low-cost tags. We can track almost every object that we can think about that we have. Then localization. This is an important application already in 5G for factories, automated guided vehicles. We need precision localization. And the speed with which the robots move in the factory is really tied to how good the localization is. And we are doing a lot of things in 5G Advanced to make the localization much better, under 25 centimeter accuracy in indoor scenarios. And if you go forward to 6G on this one, localization will expand into sensing. So we are thinking that the infrastructure for communications will not only support localization, but also behave like a radar and create a radar map of the environment, and from which we can derive useful applications like object detection, geofencing, and things like that. Cloud native is a 5G theme, network being implemented in the cloud, but still fairly well-designed cloud, meeting the needs for the communication network. But where we need to go with that is truly heterogeneous clouds, on-premise, edge, far edge. The functions can be sitting anywhere where they need to be based on latency and processing needs. And we need a simplified architecture, remove all the redundancies and introduce resiliency as the need for resiliency will be higher. That's the kind of architecture we need to evolve towards, and automation will be a key capability supported by this capability discovery of the different clouds. And finally, security is always critical. We have secure networks today, but where we want to go is trustworthy systems. So not only the network is secure, but the supply chain is secure. The software is verified automatically to be free of bugs as much as possible, and advanced privacy techniques. As we go into these true digital worlds, there's many more chances for losing privacy, and the network has to play its role in supporting privacy. So that's our sort of what 6G can do for industries.
Nice, thank you so much. Great presentation there. Just for time's sake, I want to make sure that, Benito, I'd like to hear from you in terms of your transformational process as it relates to 6G in North America.
Sure, absolutely. Yeah, my name is Ben Pietrabella. I lead the Americas Network Equipment Providers business at Capgemini Engineering. So we're all about product engineering, product design. My focus in my career has been on all aspects of product design, architecture, and communications. But now I believe 5G and now 6G really open the door for really new use cases across all industries. I think that's really important for us, right? And it's everything from incremental improvements to transformative business cases, right? So I call the term communication-enabled digital transformation, and 5G and 6G, especially 6G, is really all about disaggregating the network, ending proprietary interests, and enabling the creation of new business models. I think it's important to really in 6G to bring in the need of the business in an integrated manner into the network, because that's the way that this network technology will catch on. That's the way it will mature and become a better technology for communication. Let's get some real use cases. Let's get in front of clients and make some real changes to how they operate or how to develop new products, right? And I think the key reason behind this enablement really is based on the 5G capabilities to allow distributed applications to operate in a performant environment, meaning that, you know, if I think we talked about drones earlier, or automatic ground vehicles, if I'm deploying this level of automation in my factory or my industry, I want to make sure that the applications that are running on those devices and the applications that are really driving my business model and business use cases are fully integrated into the network, that they can get access to slices as they need them, and that they can perform as applications are expected to perform in their operating model. So it's an always-on, efficient, immersive, and excellent experience that could be many miles apart. So we're not limited by a data center anymore. We could actually be 500 miles apart. We could be operating in an airport, but have control happening in an enterprise 100 or 500 miles away. And specifically, I think 5G disrupts current technologies and really three main areas in the landscape. One is new enterprise use cases that we've been talking about this morning and probably yesterday as well, that cannot be done due to current limitations of technology. So for example, Wi-Fi cannot keep track of or can provide the same level of functionality from a networking perspective to an AGV that's moving fairly rapidly across a large environment like an oil and natural gas use case scenario, industrial operation modernization that cannot have been done previous to 5G, and also incredibly fast speeds that we all want to see in our mobile devices that include quality of service as well, right? These are reasonably defined objectives that we can definitely achieve, but we also need some innovation in how we address the use cases and how we get those use cases rolled out to the market to really reach these goals. Next slide, please. I think fundamentally, from my perspective, I think the transition of 5G is really about enabling the enterprise to integrate to the 5G networks. And really, we refer to that as the combination of OT, IT, and NT. OT is the operational business case, it's the vertically specific business case. It's the plan, it's the thing that the enterprise is going after that needs to leverage 5G. It has the operational scenarios associated. It's very vertically specific by industry, medical versus municipality versus, industrial application versus aerospace applications. And it really involves around modernizing enterprise applications as well. Think of the scenario I talked about earlier. You have now intelligent cognitive supply chain systems autonomously communicating across the ecosystem of parts suppliers and consumers to fill a need for a potentially failing part in the field, all supported by the 5G ecosystem. IT side of the house, of course, is really now, as I take this use case, can I really apply that use case to the modernization of my operating environment to my enterprise? What drones do I need? How do I connect those drones in the software that controls those drones to the network? What edge compute capabilities do I need in the operating environment to ensure that I'm performant from a compute perspective? Where's my data located? I mean, data is the heart of everything that's done in the enterprise. Is it in the cloud? Is it local? Does it need to be rationalized in the operating environment and then performed on at the enterprise layer? How do I integrate this all together? How do I leverage DevOps in order to maintain and manage this environment? And all of the interoperability associated with this multi-vendor aspect. 5G and 6G is ultimately about open interfaces, multi-vendor environments, and therefore you need to keep the agility of DevOps while at the same time being able to manage multi-vendor releases and release compatibility. And finally, third-party partner management, systems integration capabilities provided to the enterprises to enable these applications to interoperate together in the enterprise and into the network. And finally, network technology below, right? Really about how do I actually define the network? What are the functional and non-functional requirements? How does the network interface into the IT operating environment? Is it agile in a way where the drone can automatically create a slice as required in order to operate how it needs to operate, while at the same time having an IoT slice for constant communication and control? Where are the network applications hosted, and how do they actually interface to comms aware applications? So the interface between the network and the application supported by middleware as part of networking technology is very important from an agile perspective. And obviously operations, we talked about that operations earlier. Operations should have as little human interaction as possible. We talked about zero touch provisioning. I think it all needs to be part of the future of 6G. How do you create AI, ML, cognitive based operations so that you really don't need humans involved in interacting with the actual network and the solution? So these new integration patterns are very important. You can go to the next slide, please. While at the same time, ensuring that we still have a great ecosystem of application providers that can provide applications that can create the performance we need in the network. Finally, I think it's really an evolution and revolution at the same time. It's really focused on creating value better than the mobile experience and better than what we have today in the operational scenarios that we discussed currently in the enterprises, right? Eventually, we'll reap the benefit of these applications, both from an immersive perspective as well as a performance. But in order to do so, we really do need to see next generation applications built and deployed in such a way where they could leverage 5G. So I'm seeing a bunch of ISVs out there really thinking about how can I not now build my applications so that they take advantage of 5G rather than historically that we did in the past have over the top kinds of scenarios and best effort IP communication to the operating environment. It's a whole new business model for ISVs that now understand networks, understand applications, understand use cases, and can really drive that out. And really what this slide does, and we've talked about this as well, is what are the aspects of 5G that are really important to the enterprise and ultimately 6G? Security and control, reliability and resilience, mobility, being able to keep up with the drone or the automated vehicle, coverage, better than Wi-Fi, scalability and speed of deployment, low latency and high bandwidth. And you can see every use case has a variety of these needs, right? They're not all the same. If you look at predictive maintenance, clearly there's a focus there on coverage and low latency and security. But if you look at autonomous vehicles, then you have the additional need for low latency, for example. I'm sorry, low latency was in the other one as well. But you have additional needs that you didn't have before, like high bandwidth capability or speed of deployment. So there are various needs that 5G brings to the table, but the important aspect of it is that when you deploy the next generation network, you're not deploying a network for network's sake. You're actually starting with the business need, the end result of what the client is trying to achieve, and mapping that into an IT/OT and NT-based integrated solution. And I think we've got some work to do there in terms of integration across those three layers and those three elements and domains. But I think 6G will solve a lot of that problem for us. So thank you for the introduction.
Perfect. That's a great presentation. I want to segue a little bit. I want to make sure everybody had their opportunity to present, and then kind of turn that over to this question. I have two pressing questions. First one being, what problems do you see with 5G that 6G might be able to resolve? Anyone want to take a stab?
Yeah, I mean, 5G, has some limitations on uplink capacity. If you think about it, I mean, this is a bit technical perhaps, but yeah. So we designed the system thinking more about very high capacity on the downlink, but less thinking about uplink. So where the mobile devices have less power and their ability to use wider bandwidths is limited. So I think we could think about how to improve that. That's one sort of connectivity level issue. The other issue I can see is there's a lot of parameters to optimize. Machine learning hasn't been introduced in 5G at the foundation, as in it is coming as a later application. And so while it can be used to a certain extent to optimize various parameters, making the deployment more automatic, the network automation will really happen in 6G, which can substantially reduce operations costs and things like that.
I've got one as well to add to that as well, Mike.
Mm-hmm.
So I think as good technologists and engineers, we design 5G network as a great network. But if I think of the use cases, again, going back to what I said before, if I think of an enterprise wanting to integrate a particular use case via drones or some application, the 5G network as it's defined today says I have an operating environment and I can actually create slices on the fly as I need them via some human or non-human operation systems environment in a carrier or in an enterprise. What we really need is the application itself without any human intervention to have an API directly into the network and say, I need this particular type of slice. And of course, that metadata architecture has yet to be defined with these parameters so that I can actually have access to the network for a particular period of time, and then I'll release that when I'm done with it. That agility, that application to network connectivity on the fly is yet to be defined, and I think needs to be part of the 6G world.
And if I may add on to that, Mike, like if you look at 5G, it's a really optimized system, and 6G in our view is like really a system of systems. So coming back to an industry perspective, let's think of a common problem, like how to ensure quality. Like you order something and you aren't satisfied with the quality, and is it possible to trace back to the root cause? Where exactly in the supply chain it happened? Was it the procurement process or at the manufacturing process, or was it during the transportation? And I think this is where 6G can really tie together all aspects and say that, okay, and if you think of the manufacturing shop floor, that's the part where it's difficult to track. Like, can you tie bad quality to, let's say, the action of the worker who manufactured that? So that's very important. So what we are doing is we have instrumented a lot of the shop floors with cameras and LiDARs. And when we closely analyze the worker behavior and be able to tie that to the quality that was maybe observed a couple of days later. And this is where, when Harish mentioned that 5G isn't necessarily optimized for the uplink. So in this kind of application, we do really need a very high bandwidth and highly reliable and low latency uplink channel to transmit all these multimedia signals to the cloud. So there's something 6G can definitely help.
I think
Awesome.
that 5G does an excellent job of the first order integration of edge computing, but it does so kind of ad hoc. So you'll see, for example, the partnership between AT&T and Verizon to put, or excuse me, between Verizon and Amazon Web Services to put the cellular network and the edge computing network kind of into the same bucket, but they're really still separate entities. Amazon's got the servers at the base of the cell tower. Verizon owns the air interface. I think we need to see deeper penetration of edge computing and tighter integration of edge computing capabilities up and down the 6G hierarchy and the 6G value chain. So I think we need to see lots of stuff in the packet core, much more intelligence, lots of stuff on the base stations with more intelligence, lots of stuff on the endpoints with more intelligence. And all of those hierarchical intelligences need to operate seamlessly together. We need to be able to transition a workload on demand from the cloud to layers of the network-based edge right down to the endpoint device and transition it back, and do that very dynamically in 1 second timescales. We need to basically do east-west communication where multiple devices or multiple base stations are communicating with each other to share a load or to manage fault tolerance. All this takes a massive amount of intelligence buried deep in the network. And finally, that massive intelligence is absolutely essential to the pervasive AI machine learning environments that I think are going to be necessary to operate this stuff efficiently. So humans can't do it, and cloud-based AI inference, and perhaps even cloud-based AI for the learning phase, isn't going to be fast enough, or is going to basically bog the backhaul network down with transitioning all kinds of model data around. And we need to think about how to intelligently architect all of that stuff with a distributed processor infrastructure.
Oh, that's a very good point, and that's a perfect gateway into this next question. What role do you feel AI will play in the development of 6G?
I'll take a quick stab at that. I think it's an extensive and absolutely essential role. I think that we will see AI helping us invent and design the protocols and the devices that are used for 6G. So 6G base station silicon or endpoint silicon is going to be way too complex for any human to understand. So I suspect that AI techniques will be used in the design of that enabling technology. Operations of this stuff is way too complex for humans to understand. So AI, I think, is necessary to keep that network running reliably with trust and with efficiency.
Perfect. Let me open this up. I have a lot of questions pouring in. I'm going to be biased because prior to moderating this, I had some questions thrown at me from some pretty high-level people, and I wanted to throw it to this panel. This is unscripted. Number one, we've seen a lot taking place in the world of space exploration. Most recently, we have a civilian crew that's now going into space. I'd like to ask this panel, what role does 6G play in the world of space exploration, space travel?
I can say that we will also be in an exploratory mode with respect to that. We have a project now in Bell Labs to do LTE on the moon. I don't know if you've seen that. We work with NASA, and I think that's the first step towards applying our terrestrial technologies in space. I can imagine that these digital world experiences, if we create that with 6G, that can be really useful for people who are traveling in space to actually feel immersed back in Earth, or for people in Earth to be immersed in space. So I think that's an exciting possibility there.
Yeah, I see two areas, Mike. This has been, and there's probably a ton more that I can't think in real time, but one is on safety, right? The ability to have a plethora of devices on the ship where the humans are to monitor the state of the environmental conditions, operational conditions in real time, being able to get that data always on across. We talked about the network of satellites below, being able to communicate that down to Earth, ensure absolute safety and any kind of predictive failures that could happen so that no one loses their life on board, essentially, I think is a big place of the whole IoT/5G/6G kind of environment. And then the other is immersive, right? I mean, can you imagine being able to, send a probe into Jupiter and be able to have an immersive experience with, as if you're almost there, essentially, and trying to not only see in visual light, but see in other types of spectrum as well, what's happening in another planet without actually not necessarily physically being there. And that can happen from the orbiting craft to the planet. It can happen down to the Earth, but the whole immersive experience, I think, is another part of 6G that I think could be important.
Very good answer. Thank you. Elon Musk is in a rat race trying to get to Mars by 2030. What role will 6G play?
I think 6G might offer some enabling technologies that would be very helpful for Mars exploration missions. Same way that many of the NASA technologies from the 1960s enabled first generation, second generation cellular networks. I think we might turn that up on its head, and the furious research going on in the 5G to 6G transition might involve really interesting silicon technologies, really interesting radio technologies, optical technologies, all of which are particularly valuable in the very demanding efforts of space travel.
And I would also say 6G brings together communications and analytics with control. The control piece was sort of missing previously. How to do real-time control. So maybe that's something definitely will be useful for such applications.
Thank you. 6G will require an enormous amount of power. One of the things that has happened with 5G is how it's been tainted with being even associated with the coronavirus. What impacts do you see 6G will have on the environment?
So I would like to say, if I take a stab at it, I think, as I mentioned in the beginning, one of the key goals of 6G should really be to see how we can align with sustainable development goals. And one of them is really to see how to reduce energy consumption. And that's something being considered in 5G. And I think when we go to 6G, and we talked about AI before. So I think one of the important use cases of AI would be to minimize energy consumption over the overall network. And about that, I'm very hopeful about.
Yeah, can I answer? Yeah, so I think we should also think about how 6G enables energy efficiency and sustainability overall. In addition to 6G itself being energy efficient, I think it can reduce travel significantly. That saves energy. It can support more autonomous operations. Again, that will save energy. So I think in a variety of different sectors, I think having a more sophisticated connectivity solution is definitely going to help reduce energy. And if you look at the sample, I think we will have a big benefit from 6G.
Yeah, I think you're right. I think the use cases are a big piece of it. The immersive experience is very energy efficient because you don't have to travel. In addition, but the network itself, allows for more openness and multi-tenancy. Now you've got the ability for, tower and access providers to have really a plethora of carriers or operators attached to them, as well as private networks as well. So you have efficiency in terms of density of the access environment, the ability to now, within the access environment, route the service to whatever carrier and network needs to get to it, and ultimately maybe even have a player like a web scaler provide services to the enterprise across the geography. So you get efficiencies in the network as well because of the disaggregation and ability to separate the user and the use case from a specific network or physical topology, right? So I think there's density and efficiency there as well.
I'd like to see every 6G outdoor node be its own energy microgrid. So you got a 6G tower, maybe 20 to 50 meters tall, put a wind turbine up there in a way that won't interfere with the antennas. Put a solar array on the ground down next to it, and put a battery plant adequate to run that cellular infrastructure in the device. And then this whole thing can be grid connected so that if the wind turbine and the solar array generate more energy than that 6G node needs and the batteries are topped up, it can drive that energy into the grid. If the grid is in crisis and there's an extra couple of thousand joules of energy sitting in those batteries, it might be reasonable to borrow a little bit of energy from the entire 6G grid reserve to backdrive the grid during a couple of hours of peak demand. That sort of thing is becoming feasible from both a cost and a technology perspective. And 6G needs to not be a big millstone around the neck of the electric grid. It needs to help save the electric grid from its impending crisis.
Charles, thank you so much for that. I want to, challenge everyone, starting with you, Charles, and Ben. This is all great. And I started off deliberately talking about space, and then I went into the environment. Let's talk about developing countries. I'll call them formerly known as third world countries. What does 6G do to places such parts of Asia, the continent Africa? I could talk about space, I could talk about the environment, but the practicalities in a third world country, what can we do? What's the game changer here?
Connectivity is a great equalizer, and anybody with appropriate talent and a little bit of technology can be as effective as I am sitting here in Chicago as a CTO of a company. So let's make that happen. But to make that happen, we've got to drive at least an order of magnitude of cost out of both the endpoint devices and the network infrastructure. One way to do that is to take a look at the advances in computation that took what was heretofore a $500 computation infrastructure and turn it into a device that we might sometimes call a Raspberry Pi today, a little $35 circuit board about this big that has very similar functionality to that $500 computer. And they're very pervasive in lots of really interesting low-cost ventures. What we need is the Raspberry Pi of cellular infrastructure, something so that the endpoint in a device costs a couple of bucks, and the endpoint for a microcell costs maybe the same $35 that a Raspberry Pi does. If we can feed them with fiber optic connectivity, figure out a way to get that deployed cheaply and deeply, that's also helpful, because in these third world countries, copper connectivity is sometimes problematic because of the scrap value of the copper. People tend to rip it up and disconnect your network elements. Fiber doesn't have an intrinsic scrap value, so I suspect that that's going to be an important consideration. And then, of course, the energy to drive it would have to be done with the distributed grid.
Yeah, I agree with that. And I think there's options. Like, there are great companies out there looking at miniaturization and power, savings on the chip and IC side. It'll make the RF access technology more cost effective to deploy. I think we've got options, where you see real estate companies now looking at building venues that have wireless connectivity that provide access to multiple carriers. I think that could be a play for developing as well. So venues, real estate, miniaturization of access technologies, SD-WAN as a way of backhauling the information to the main internet. So there are options. I mean, they all take some level of investment, but there are options out there to do cost-effective, cost-effective rollouts of new technologies in developing companies that are cheaper, that have a significant upside, where companies would say, you know what, I'd like to provide this connectivity in a venue because there's an upside for me to make money on that as well, because developing companies are obviously have many types of sports venues as well that create and generate revenue too. So I think we have more options because there's diversity and multi-tenancy that 5G brings to the table, along with miniaturization and power savings that will ultimately drive down COGS, where we could do some things there as well that have great business cases behind it and actually help a lot of the folks that are in those countries as well. So I look forward to helping work those as well as part of my job across the globe, to look for solutions for private companies to help not only themselves, but also help the public as well.
The other thing I'll add is the non-terrestrial networks, right? That's going to be an integral part of 6G. and it will be designed to provide connectivity to all regions of the world, and especially the regions that are underserved today. So I think that's something to look forward to in the future.
Also, if I may add, so one of the key differences when you mentioned the so-called underdeveloped countries and other countries skilled economies is the presence of skilled workers or technicians. And I'm speaking of industry or manufacturing context, which is often lacking in the other countries which are sort of upcoming. And this is where 6G can really help. So the skilled technician can be remote in his or her own country and still be able to have a 360-degree view of the inside of the factory or the workflow, either through real-time video stream or LiDAR stream, or even going a step beyond. Think of a local technician wearing a AR headset and that being streamed live real time to the skilled technician abroad. And that person will be able to control it just as good as he or she being there physically present. So that definitely is interesting use case which 6G can provide.
Perfect. Good point there. I appreciate that. When I look at 6G, and again, one of my for Digital Mindstate, our company, which really focuses in on disruption in terms of lifestyle and entertainment, and these are all the early adapters to all the latest and greatest in technology. We're really big on how 6G will usher in the future of work. As I mentioned before, the next 10 years is more important than the last 100. Right now, in today's date, there's, I think the latest data that I have, there's 30% of new jobs that hasn't even been created. 6G will play a role in ushering that in. But be that the good part, I'm kind of curious on this word, and I'd love for input from anyone on this panel as it relates to surveillance, privacy, and as we move even further into an Internet of Things world, what does surveillance and privacy look like?
Well,
anyone want to take a stab at that? Sorry, I'm lightweight, somewhere between 6G solving a lot, and then what does sci-fi look like afterwards?
Yeah, I think there's a danger that we put technology to use to do surveillance to a very large degree. I mean, as we enable new capabilities in the network like sensing, radar functions, I think it's possible to have a very rich representation of everyone and everything, and we have to be extremely careful about how that's used. There's no doubt about it. At the same time, the same 6G technology will also enhance privacy-preserving technologies, right? That goes with it. So, for example, if you're sharing your video, there will be technology that is able to scan that and block out things that you don't want to reveal. So I think AI will learn your preferences. So today we are asked to answer questions on a form saying, yeah, I'm willing to share this, I'm not willing to share that, etc. But I think this will become automated. So based on your sort of lifestyle and preferences, machines will learn what you like to share and what you don't like to share, and start applying that across the board on any information that emerges from you. So if it's video, it starts to scan the video and flag that or block that, remove contents that you don't want to share. So I see technology really helping privacy in the future. Just as it can enable surveillance, it can also enable for privacy, I guess.
Yeah, good point.
Governments are going to do what they're going to do, and there's not much that we can do to prevent that. Big corporations, the big five kinds of corporations, are going to do what they're going to do, and there's not a whole lot we're going to really do as a society to prevent that either. We can try to regulate them, but that's only diminishing returns. So I think that the human race is going to have to sort of live with the fact that privacy and surveillance is part of reality.
It's the new norm.
Yep. The flip side of that, however, is 6G and connected technologies in general really help us keep track of the government and help us influence governments who aren't doing things in our best interest, right? And vote them out of office if they really screw up and and start to turn too totalitarian on us. So I think that the extra connectivity and the extra access and the extra capabilities that this brings to the average citizen may be a new set of checks and balances against those governments and corporations running amok with all this surveillance data that they'll inevitably have.
Perfect. Guys, I want to thank you. I could have kept this going for another hour. This is a rock star panel. Each one of you guys have poured some great insight for our listeners. I want to thank you very much for your time and 6G Symposium for having us. Thank you, guys.
Thank you so much.
Thank you, everyone.